Welcome back, Internet. In today's video, we're going to be looking at Chapter 5 of Practical Malware Analysis. The labs say to analyze this DLL inside of IDA Pro. I've already loaded it up, so let's take a look at it. Question number 1 says, what is the address of DLL main? IDA Pro is going to drop you right here. All you have to do is right click, text view, and here you go. Here's the address. It's 1000D02E. Question number 2 says, use the imports window to browse to get host by name. Where is the import located? So we're going to go to the imports tab, arrange it alphabetically. And if you know about ASCII, uppercase letters come first. And here we go. Get host by name. It is located at the address 116.3.c. It says use the import window to browse to get host by name. Where is the import located? Okay, so in the next question, how many functions call get host by name? All you have to do is press Ctrl X or just X. Double click it first, click on the name, and press Ctrl X. And we see here 1 of 18. So if you look here, let me make this a little wider. There's a type. These are pointers, and these are copies, but this is actually reading the value pointed to by that pointer. So it actually gets called 9 times by, let's count how many different functions. Here's 1074, calls it 3 times. So that's one function. Here's another function that calls it 3 times. So that's 2 functions. Here's the 3rd function, 4th function, and 5th function. So it gets called a total of 9 times by 5 different functions. Okay, the next question says, focusing on the call to get host by name located at 1000.1757, can you figure out which DNS request will be made? So all we have to do is click cancel. We're going to press G. We're going to enter 1000.1757, hit OK, and this is the call it's referring to. Can you figure out which DNS request will be made? So it's gonna look up whatever is stored in EAX. We see this value here being used to load EAX. So let's double click here. And it says, we see a bracket, this is RDO pics.practicalmalwareanalysis.com. Okay, but this RDO part is a little sketchy because that's not a valid domain. So let's go back. I'm pressing escape. And we see here we're loading that value into EAX, and we're adding D, hex D, into EAX. Hex D is 13, and then we're pushing EAX. So let's go back into here, double click it once more. 13. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So it's going to be pushing everything after that 13th character, and that's what the DNS request will resolve to. So the next question says, how many local variables has IDA Pro recognized for the subroutine at 1000.1656? So again, I'm going to press G. I'm going to enter 1000.1656. I'm going to hit OK. And it's saying how many local variables. So if we scroll up here, we can see IDA Pro recognized 1 parameter, which is the next question. So we took that one out of we already took care of that question. And all we have to do is count these variables here. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, and 23 local variables. The next question says, what is happening in the area of code that references Oh, I'm sorry, I skipped one. It says use the strings window to locate the string command.exe/c in the disassembly. Where is it located? To solve that one, we're going to click on this view menu. We're going to click open subviews. Open subviews. We're going to hit strings. I'm going to press Control F. I'm going to enter CMD. And we see it's here. We make this a little larger. We've got its address. So it's located at 1009 5B 34. I'm gonna double click it. Okay, so the next question says, what is happening in the area of code that references this string? So I'm gonna hit Control X. We see that it's called from one function. I'm gonna hit OK. And we need to try to figure out what's happening inside of this code. So let's scroll up a little bit. And I'm going to click on View, Graphs, User Cross-References Chart. And we see that our address was populated here, which is good. We're going to go one depth, hit OK. And this function is massive. Let's zoom in and let's see what's called. We don't know what's happening here, but let's see what kind of function calls it's making. We see a close handle, string concatenate. We see a close socket. So we know some network activity is going on. We see memory being set, string copied, memory copy, set current directory, get system directory. We see a receive here, a get current directory. We see a read file, string copy. We're creating processes. Another function we don't recognize. So let's close out of this. Let's right click. Let's go into graph view and let's see what kind of strings we see. We see a high master here with a bunch of percentages. This looks like it's going to be a time format. Welcome. Welcome back. Are you enjoying today? And we see these time strings. So let's go back by pressing escape, scrolling down. We see a command.exe or a command.exe, which is for Windows versions prior to 2000. We see a quit, exit, cd, end magic, idle, uptime, language, robot work, mbase, mhost, module, minstall, inject. We see iExplore. So it's pretty safe to say that we're setting up some sort of remote shell. Let me just rename this function really quick. To rename it, I'm going to click on it, hit the end character, and I'm going to name it setup remote shell. Okay, so the next question says, in the same area at, let me press G, start going to it. It says 100, 101, C8, which is still in this function. It says in the same area, it looks like D word 1008 E5C4, which is here, is a global variable that helps decide which path to take. How does the malware set this value? So we're going to double click on it and we can see it's uninitialized. So we're going to hit Control X to see what cross references there are. And we can see there's a move instruction. EAX is being loaded into that value, and 2 comparisons. So it's going to be safe to browse the code around this first function. So hit OK. And we see a call to this function. Whatever's returned from that function is being moved into this value. So that's how it's going to get its value. Let's check that function out. Okay, so it's making a call to get version X. It's exclusive ORing, so it's setting EAX to 0. Then there's this comparison. So get version takes, I believe, 1 parameter, and it's going to be this version information, and then it's going to initialize that version information structure. So what we're getting is the dword platform ID. We're comparing it with 2, which is the version, Windows version NT. So I'm going to click on this number 2 here. See, it's highlighted. I'm going to right click. I'm going to go to symbolic constant, use standard symbolic. I'm going to search for version. This one, version platform Win32NT. And then it's saying if that value, if they're equal, we're setting AL to 1. So we're pretty much checking to see if this malware is running on a Windows 32NT operating system. So let's press N on this function. Is Win32NT. Hit OK. Hit escape. And we're going to rename this variable as well. We're going to name it is Win32NT. And there you have it. That's how it's being used. Next question says, a few hundred lines into subroutine at, let me press G, 1000 FF58. It says, at this address, a series of comparisons use mem comparison to compare strings. What happens if the string comparison to robot work is successful? So let's scroll down and let's look for that string robot work, I believe it said. Yes, robot work. Am I still in the correct function? Let me switch into text view. I'm going to press Ctrl G again. I'm going to enter that value one more time, just so it's easier to find that string robot work. So here we are. Here's the mem copy I was talking about. It's successful when mem copy returns 0. What was the question asking one more time? A few lines into subroutine, blah blah blah, series of comparisons. What happens if the string comparison to robot work is successful? So if it's successful, if it's not 0, it's going to take this jump here. Where did we jump? Here. What are we doing? We're pushing 5, we're pushing M base, pushing EAX, which is currently host destination. Wait, if it's not 0, no, I'm sorry, it doesn't take this jump. So it's going to do what's after here. And there's a function call, it's pushing whatever this local variable S contains. Jumping into that. We see a registry key here, registry close, registry query. We see the string work time. We're querying the registry. see a call to this function. We see a malloc. So let's hit escape. Memset. There's another unknown function here. And we see a send. So let's escape. And then we close the registry keys. So we're going to query the registry keys and we're going to send those values to, I guess, the attacker. Let me just double check. Let me see. What question was that? This is question number 10. And the official answer says the registry values located at the one we saw work time are queried and sent over the remote shell connection. Yeah, so exactly what I said. The next question says to find out what the export PS list does. So let's click on this exports tab. We can see PS list is right here. Let's double click on it. It's a fairly small function. There's a comparison while we're moving one into this uninitialized value. We're calling this subroutine. And what are we doing? So this looks pretty familiar to the last function we took a look at. The major version. So major version 5 has to do with Windows Server 2000, Windows XP, and I believe Windows Server 2003. I'm not entirely sure, but it's fairly simple to look up. I looked it up earlier. If it matches, it's gonna push 1, pop EAX, which is a funny way of setting EAX to 1. We're pretty much making sure we're running on one of those platforms. If not, we take a jump, we return 0, saying we're not running a valid operating system. Testing it. And we see this jump, it pretty much just exits. But if we're running a valid operating system, we'll push this string. We'll call string length on it. We're testing it, which means to and. We're pretty much checking if it's 0. We see a pop ECX, we're clearing the call stack. And jump if not 0. If it's not 0, so that means if the string passed into this function contains any characters, we'll take this jump. So not empty string. Okay, let's find out what happens if we have an empty string first. We'll push EAX, which is currently, it's going to be 0. And then we call this function. We see a create tool help 32 snapshot. So we're probably going to start enumerating through the running processes. We can see process ID, process name, and we call this function. Double click on it. We see on X install DLL, F close. So we're going to read this DLL here, or import it. One of the two. We're using that DLL somehow, and we're going to start enumerating through that snapshot. We're opening a process. Enumerating process modules, get process file name. We're pretty much getting information on that process. Then we call this function here, which looks like the same one from earlier. We close that handle, process 32 next, close handle. So hit escape. Let me just let me just click on this call, make sure I'm not missing anything. So sub, blah, 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 escape. So yeah, we're enumerating through that list. We're jumping here, popping ECX, we're returning. If I'm not mistaken, there should be a call some network activity. I recall seeing a send function somewhere. Let me see if I can find it. guess not. So we're pretty much enumerating through the running processes. And over here, if the string is not empty, so we're assuming it's going to have some sort of value. We're pushing 0 and that's string. And we see a repeat store string, create tool help 32, process 32 next, string comparison with the string you passed in, and this pretty much the process we're finding. We're enumerating through the processes. We're comparing it to what we passed in. And then we see a call to this function here, failed to send. So we can assume we're getting information on a specific process and sending that information back to the attacker. The next question says to use the graph mode to graph the cross references from sub. Let me go to it, press G. It's 1000. 4E79. Hit enter. So we're going to use the graph from. So we want to see what this function is calling. We can right click up here, click on graph view, or maybe we can't. I don't see it up here. We can just right click, cross references from, and here we go. And it says which API functions could be called by answering this function. So we see a get system default, language ID, sprintf, and string length. Based on the API functions alone, what could you rename this function? If we look down here, we see the send, so we could probably rename this to something like send system language. Hit OK. And are we done with that one? We're done with that question. So question number 13 says, how many Windows API functions does DLL main call directly? So we're going to go into DLL main. We're here. I'm going to click on its address, click on view, open subviews, go into, I'm going to go into graphs, use the cross references chart. We're going to see what functions it calls, so we're going to hit enter 1, hit OK. And DLL main calls string and copy, string and comparison, create thread, string length. So it makes a call to 4 API functions. And how many at a depth of 2? So we're going to do the same thing. We're going to click on view, graphs, user cross references chart. This time we're going to enter the number 2, hit OK. And it's a lot bigger this time. I'm going to just zoom in for you guys really quick and try to scroll through this quickly so you guys can see what functions it's importing. And that's it. So the next question, which is question number 14, at address, let me press G, 1000, 1358, there is a call to sleep, an API function that takes one parameter containing the number of milliseconds to sleep. Looking backward through the code, how long will a program sleep if the code executes? So we're passing it in EAX. We see a multiplication with this hard-coded value. Let's open up our calculator. Click on view. We're going to click on programmer. And we see this 3E8, that's hex, 3E8. Hit decimal, so it's 1000. We still don't know what EAX is currently holding. We see a call to ASCII to int. And then here we see EAX being loaded with the value. So let's double click here. And we see this is CTI 30. hit escape, and we see that old familiar add hex D to EAX. We're pretty much just going to take this 30 here. I'm not going to count it this time because you guys saw what I did last time. Same principle. So we're getting this 30, we're multiplying it by 1,000. So for those of you bad at math, that's going to be 30,000, confirmed by entering it into the calculator. 30,000 milliseconds comes out to 30 seconds. So we're going to sleep for 30 seconds. The next question says, at 1701 is a call to socket. What are the three parameters? So the three parameters are 216. The next instruction says, using the MSDN page for sockets and the name symbolic constant functionality in IDA Pro, can you make the parameters more meaningful? What are the parameters after you apply changes? So IDA was nice enough to tell us that this is AF, this is type, and this is protocol. Let me click on here, right click, symbolic constant, use standard symbolic constant. And if I'm not mistaken, this is iStream. No, what is it? AF. It's AF something, I think. I really don't want to exit my virtual machine. Probably should have had this handy. Alright, we have no choice. Okay, so we're going to look up MSDN socket, hit enter, click on here. So AF, it's AF underscore INET. I knew it was, but I forgot the underscore. So right click, symbolic constant, use standard symbolic constant, EAF underscore INET, hit OK. The next one is type of one. So let's scroll down, we see type, it's a stock stream. Go back into it, right click, symbolic constant, use standard symbolic constant. What was it called? Sock stream. Let me just do it this way, sock stream, hit OK. And the last one says a protocol of 6. That is going to be IP protocol, TCP. So click on the number 6 till it's highlighted, right click, symbolic constant, use standard symbolic constant, and we're looking for IP proto TCP. There you have it. The next question says to search for usage of the in instruction opcode ED. This instruction is used with a magic string VMXH to perform VMware detection. Is that in use in this malware? Use the cross references to the function that executes in the in instruction. Is there further evidence of VMware detection? So we're going to go search for a sequence of bytes. We're looking for the opcode ED. We want to find all occurrences, hit OK. And we see the instructions here. We found in, let's see if there's any other in instructions, which there's not. So let's double click on this. They said that there's the magic, what did they call it? Magic string VMX. All we see is this hard-coded value here, but 56 is hex for B, 40 is hex for M, 58 is hex for X, and 68 is hex for lowercase h. So let's return from this function, or let's see what called this function. So we'll click Control X, hit OK. And we see the string found virtual machine install cancel. So there is VMware detection. The next question says, question number 18 says, jump your cursor to 1001 D988, hit OK. And what do we see? We see a bunch of garbage bytes. Looks like random ASCII's, probably encoded somehow. So I've got my cursor on there. The next questions, oh, it says, what do you find? I already told you what I found. Garbage bytes. Question number 19 says, if you have the IDA Python plugin installed, included with the commercial version of IDA Pro, run some py file that's included, an IDA Pro Python script provided with the malware for this book. Make sure the cursor is at this value. What happens after you run the script? So let's find out. We're going to click on File, Script File, navigate to the Python file that's included with the labs. If I could find my labs. Oh, I'm sorry, it's on my desktop. So here we go. And here's the py file. I'm gonna hit open. And we saw this change. It says XDOR is this backdoor string decoded for practical malware analysis labs 1, 2, 3, 4. So if we click on this value here, this address, and hit the character A, it'll fix it for us. Number 20 says, with the cursor in the same location, how do you turn this data into a single ASCII string? I just taught you guys how. Hit the letter A, open the script editor. How does it work? So let's minimize this, close my calculator, right click, and we're gonna hit open with. Let's find Notepad. Where is Notepad located? This would help if I knew where Notepad was. Let me just change the file extension. So it's getting where our current cursor's at. There's a for loop. It's looping through 50 characters, or 50 bytes, I should say. B equals byte. So it's iterating through each byte. Decode byte, it's doing an exclusive OR with hex 55, and it's patching it. So all it's doing is it's exclusive ORing it with 55. Ta-da! That's the labs for chapter 5. I hope you enjoyed this video, and I'll catch you guys next time.